Hello, this is the TI84 guy, and I'm back. I wanted to show you guys a program that I've written called ASEQUERY, and it's basically a program that handles arithmetic sequences, geometric sequences, arithmetic series, geometric series, and I wanted to demonstrate how flexible it is and how important it is if you can have this program on your calculator. If you're taking the ACT, if you're taking the SAT, if you're taking the SAT Math Level 1 or 2, how this program could save you a lot of time and get you some questions answered pretty easily. All right, so I'm going to jump right into it, and I'm going to demonstrate. I'm going to try to do 10 problems, and I may go a little quickly, but if you have any questions, just put comments in and I'll respond. But I wanted to try to show you pretty much how flexible it is. So I'm going to start by showing you a program that is an arithmetic sequence, and then we're going to go from there. All right, so let's go here. All right, so let me make sure this is in the camera and that you guys can see it, and then we'll go from there. All right, so this problem is on the Math Level 2 exam, and it's a number 40. The question says, if the 20th term of an arithmetic sequence is 100 and the 40th term of the sequence is 250, what is the first term of the sequence? All right, so let me just jump in by showing you how I would use this program. Let me turn it on. Let me clear all this out. Okay, so I'd go to the program, and it's called ASEQUERY, and it's basically I took two words, sequence and series, and kind of smushed them together and made it ASEQUERY. All right, so press enter again. Very first question is going to ask you is, does this series sequence have any variables in it? If it doesn't, you say no. In this case, it doesn't. So then the next one is going to say, okay, what are we dealing with? Are we dealing with this arithmetic sequence or series, or are we dealing with a geometric sequence or series? All right, so you have to tell it what you're dealing with. In this case, the problem says it's an arithmetic sequence, so we would choose option 1, press enter, and then it's going to ask you for the very first term that you have. In this case, the very first term that we have is 20. We have the 20th term, and the value is 100. And then we have the 40th term, and we have the value is 250. Press enter. Now it's gonna ask you, well, what do you want to know the value of? In this case, it says, what is the first term of the sequence? So we would put in a 1 and then press enter. So it would say that the value of the first term is a negative 42.5, which would be option B. Now, let me show you a couple other things. This program is going to always try to generate the equation for you, right? It's always going to try to generate if it's an arithmetic sequence, it's going to generate that equation. If it's a geometric sequence, it's going to generate that equation, and it's going to store it in Y1. So if you want to graph it, or if you want to look at the table, right? As you can see, the very first term here is a negative 42.5 as we expect. The second term is a negative 35, so on and so forth. So if you want, this program is going to always generate the equation for you and store it in Y1. Okay, all right, so let's go to the next one. All right, here. All right, so the next problem that we're looking at here, let me make sure I might zoom in a little bit just to, all right, right here. It's saying, this is from a Math Level 1 exam, and it's saying number 40, it says, at the end of 1990, the population of a certain town was 6,250. If the population increases at a rate of 3.5% each year, what will the population of a town be at the end of 2005? All right, and it gives you 5 choices. Okay, this is basically an exponential growth problem, right? But an exponential growth problem is basically a geometric sequence. They're like sisters, okay? And when you're looking at the SAT or ACT or the Math Level 1 or 2, you can treat those exponential growth problems or exponential decay problems as a geometric sequence. And so that's what I'm going to do. So I'm going to use the program again, and I'm going to press, let me make sure I'm in here. I'm going to press enter. It doesn't have any variables, so I'll press option 1. And in this case, we're dealing with a geometric sequence, so I'm going to choose option 3. And so it says at the end of 1990, there was 6,250. So that's our initial value. So I'm going to say that's when we start. So I'm going to say the term number is actually 0, okay? So then I'm going to put in 6250, right? And then the following year, which would be 1991, at the end of 1991, the population grew by 3.5%. So term number 1 would be 6250, right, times 1.035. So this is saying the population grew by 3.5%. So that's our first term. All right. So then I press enter. And again, it's asking me, what term do you want? Now, it's saying we want the population at the end of 2005. So here's how I would do it. I just say 2005 minus 1990. And of course, that's 15 years. So that's the 15th term, but I just let the calculator figure it out. All right. So it says at the end of 2005, there was 10,470.93019. Now, we can't have 0.93019 people, so we would just round it off to 10,470. So the answer would be choice E. All right. So again, so far, 2 basic sequences, arithmetic, geometric. All right. So now we're going to move on. Okay. Now, this is from an ACT exam, an old ACT exam. I want you to see again how you can use the program to make your life much easier. Now, if you look at this, this is a number 59 problem. There are 60 questions on the ACT math section, and they get increasingly difficult. So when you get to the number 59 question, that's generally considered a difficult problem. And if you don't remember the arithmetic sums or series formulas, then this problem is going to be hard for a lot of students, which is why it's considered a 59 question. But in this case, I would use the program again. So let me kind of get this so everything is in there. So let me press enter. All right. Does this one have any variables? No, we just have a bunch of numbers. All right. So what kind of question is this? This is an arithmetic series. How do I know that? Because we're taking consecutive positive integers, and we want the sum of the first 60 positive integers. So we want the sum and its consecutive integers, so we know it's an arithmetic series. Press 2. So the very first term is 1. The second term is 2, right? So then it's going to ask you, well, what do you want? Do you want to know the sum of a certain number of terms, or do you want to know, you're given the sum and you want to know how many terms are in that series, right? Later on in the video, I'm going to show you, give you an example of how you would use number 2. But for now, we want to know what's the total, what's the sum of the first 60. So we would press 1, and then we would begin at 1, and we would end at 60. So this is telling the 61st, or the 60, the sum of the 60 terms. All right, so press enter, and it says that the sum of the first 60 positive integers is 1,830, which would be option D. Okay, pretty straightforward. All right. So now I want to show another example. And this one is coming from the Math Level 2 book. And let me get it adjusted here so we can see what we're dealing with here. All right, so here we go. All right, so this is from the Math Level 2, and it says, what is the sum of the infinite geometric series? And it gives the terms. First term is 1/4, the second term is 1/8, the third term is 1/16, the fourth term is 1/32, on and so forth. All right, so we want to know what's the sum of this infinite geometric series. They tell you that it's an infinite geometric series, but even if they didn't provide that information, you should be able to tell that the common ratio is going down by a fixed percentage, and it's less than 1. So if you have a common ratio that's less than 1, then you should know that you're dealing with an infinite geometric series. All right, so how I would handle this, we're going to pull the calculator back in here again. I would press, there's no variables here, and then I would choose option 4, because this is a geometric series. It tells you that it's a geometric series. So the very first term, I put in 1, and then I would put in 1 divided by 4. That's the value of the first term. The second term would be 1 divided by 8. All right? And then it's going to say, again, what do you want? Do you want the sum or do you want the number of terms? In this case, we want the sum. It tells us that we want the sum. Now, I've coded this program to say that if you're dealing with an infinite geometric series, you've got to indicate that, because there's no way to indicate in the program that there's no infinity symbol. So what I've done is I say, okay, we're going to start at 1. Now, and to indicate that you're dealing with an infinite geometric series, you would put 999 in the ending slot and press enter. And then it tells you that the sum of an infinite geometric series, of this geometric series, is a half or 0.5, and that would be option 8. So the program knows that when it sees 999, that it's potentially dealing with an infinite geometric series, and it knows kind of what to do from there. All right, so hopefully that's pretty clear. All right, so we're going to go on to another problem. And so far, all of the problems that we've had have only had numbers. But I want you to see that this program can also handle variables. All right, so this problem here is taken from an old SAT exam. Let me get it set up here so that we can see what's going on. All right, and I'll read it. It says, in the increasing sequence above, and it has the sequence, the very first term is y, the second term is 2y plus 7, the third term is y plus 6, okay? And then so forth and so on. So it says, in the increasing sequence above, the first term is y, and the difference between any two consecutive terms is 3. What is the value of the fourth term in the sequence? We have 5 choices. All right, so, okay, we've got variables in this one. So again, I would grab the calculator. All right, I would grab the calculator, press enter. Now, it's asking us, does this problem have variables in it? You bet it does. All right, so we would press 2. All right, now, what are we dealing with? And because we know that the difference between any two consecutive terms is 3, then we know that we're dealing with an arithmetic sequence. All right, so we would choose option 1. Now, so the very first term is y, but the program only recognizes the variable x, so we have to use the variable x. And then we would go, the second term is 2x plus 7, and the third term is y plus 6 or x plus 6. All right. Now, let me say something that I neglected to mention before. Whenever you're dealing with either arithmetic sequences or geometric sequences and all you have are numbers, you have to have 2 terms and 2 values. Once you have 2 terms, 2 values, the calculator, the program will figure out what the equation is, all right? If you have variables, you have to have at least 3 terms. So let me repeat that. If you're just dealing with an arithmetic sequence or a geometric sequence and you know what the numbers are, you have to have 2 terms and you have to know the 2 corresponding values, right? If the sequence has variables in it, as this one does, you have to have 3 terms, all right? And this particular problem, they gave us 3 terms. So now we press enter. Now, so the program is going to say, because there are occasions where there could be potentially 2 solutions. So you have to tell the calculator or the program, where do I want to start? Generally, what I would advise is that if you're given a bunch of choices, I would choose the one in the middle. All right, just to kind of be safe. So I would say, let's say it's 5. So you press enter, and then it calculates what the value of y or x is. It says x is equal to a -4. So what that means is our very first term would be a -4, and then our second term would be 2 times a -4 plus 7, which would be a -1, and then our last term would be a -4 plus 2, or plus 6, which would be a value of 2, right? Now, as I mentioned before, whenever the program, whenever you use a program, it will calculate the equation, and you can use the table to actually find the value. So let's go here, start the table at 1, look at it. So it says here, the very first term is a -4, as we saw. The second term is a -1, which we also saw. The third term is 2, and the fourth term is 5. We're looking for the fourth term in this problem, so the answer would be 5. Okay. All right. That's for an arithmetic sequence. It has a variable. So let me show you another problem here. And this one is a problem that's a geometric sequence that has a variable in it, and how we would use that. All right, so here, it's a number 21 problem. It's from the Math Level 2 exam. It says, what number should be added to each of the three numbers 1, 7, and 19 so that the resulting three numbers form a geometric progression? So basically what it's saying is, what number can you add to 1, 7, and 19 so that the resulting numbers are a geometric sequence? All right. Now you can easily back solve this just using one of these, choosing the numbers and then trying them to see which one yields that. But since we have a program, I'm just going to use the program and go from there. All right. So press enter again. Now, even though this one didn't actually give us a variable explicitly, it's asking us what number should we add to each number. So it's like it's saying, okay, I need you to find the number. So we can say, yes, it actually has a variable. In this case, because we know it's going to be a geometric progression or a geometric sequence, we're going to choose option 3. And then, so the very first term is 1 plus x, right? The second term is going to be 7 plus x. The third term is going to be 19 plus x, right? And then press enter. And again, it's going to ask you to guess. We can use 4. So we'll put 4 in there and see what we get. All right, so it's saying that the value of x is 5. So it's saying if you add 5 to all three of these numbers, it will give you a geometric sequence. So let's look at the table. So 1 plus 5 is 6. 7 plus 5 is 12. 19 plus 5 is 24. So that is a geometric sequence. The common ratio is 2. If you looked at the y equals, you would see that the actual equation is 3 times 2 to the x power. All right, so everything works out there. So the answer for this one would be 5. All right, sounds good. All right, let's move on. All right, the next thing I wanted to show is I wanted to show you a couple things that sometimes the arithmetic sequences in series or geometric sequences in series, they'll be kind of disguised and they won't be presented kind of in the form that you're kind of accustomed to. So let me show you what I'm doing here. Okay, this problem is actually taken from the ACT Red Book. It's a number 53 question, and I'm going to read it. It says, on the first day as a telemarketer, Marshall made 24 calls. His goal was to make 5 more calls on each successive day than he had made the day before. If Marshall met but did not exceed his goal, how many calls had he made in all after spending exactly 20 days making calls as a telemarketer? Okay, so this is a word problem. It doesn't say that it's an arithmetic series, but if you understand what an arithmetic sequence or series is, then this problem it should be obvious that it's an arithmetic series. One of the clues is he makes 5 more calls each day. All right, so it's going up by a constant amount, and then at the end of 20 days, we want to know how many calls he made altogether. All right, so what I would do here, again, I'd use the program. There's no variables here, so I'd press option 1. Again, we know, or you should know, that this is an arithmetic series, so you press option 2. The very first day, he made 24 calls. On the second day, he made 24 plus 5, so he made 5 more calls. So he made a total of 29 calls. Now, again, we want to know what's the sum, what's the total number of calls that he made over 20 days. So we'd choose option 1. We begin it at 1. And we would end it at 20. Press enter, and it says, for 20 days, he made exactly 1,430 calls, option D. Okay? Hopefully that's crystal clear. All right, let's go to another problem. All right, so here's another example. Let me make sure I get this in. This is a number 54 question. And again, on the ACT, this is from the ACT, you have 60 math problems. They get increasingly more difficult. So a number 54 is generally considered a difficult problem. If you have this program, this is a pretty straightforward problem. All right, so let's look at it. Okay, it says, the table below gives some x and y pairs that satisfy a linear relationship. What is z equals? Okay, and then it gives you the table of values here, all right? So it gives you a table of values. Now, as I mentioned before, exponential growth problems are basically similar to geometric sequences. In this case, linear functions or linear relationships are basically similar to arithmetic sequences. So we can use this program, even though it's asking for a linear relationship, we can use the arithmetic sequence program. So this is how you would do it. Even though it has a variable here, right, it gives us enough value, enough information in the table that we can actually figure out what this is without having to use the variable feature here. So I would choose no here. And then I would say, okay, what do we have here? It's a linear relationship, so I would choose, oh, that's similar to an arithmetic sequence. Press enter. Okay, so the very first term that we have is the -2, and the value of that term is a -7. The term here, the term number is 2. The value is 5. All right. Now, it's asking us what term do we want? In this case, we want to know what the -3 term would be. So we put in a -3, and it says the value of the -3 term is a -10, so that would be option F. All right, so that's pretty straightforward. But again, even though this is not technically an arithmetic sequence, for all intents and purposes, you can treat it as such on the SAT, ACT generally, all right? And you can also use this program. Now, I'm going to wrap this up by going over 2 more programs and showing you a little bit more flexibility. All right, so what we have here is we have a problem. It says, if you have an arithmetic sequence of a -2, 5, and 12, then what term has a value of 124? So it's saying if you were to write these terms, this is the first term, this is the second term, this is the third term, then it says ... There's a value out here, 124. What is that term? All right, and we have our numbers here, 17, 18, 19, 20, 21. All right, so basically we can use this and we can say, okay, we're trying to find this term. So let's say, yes, it has a variable. We'll put that. And it tells us that it's an arithmetic sequence, so we would choose option 1. Alrighty, let me get this all set up here. Make sure everything is in focus. All right, and then the very first term is a -2. The second term is 5. Now the third term, we're going to say the third term, we don't know what it is, but we do know the value. The value is 124, and that's what we're trying to solve for. So then we press enter. And then it's going to say, okay, give me a guess. And I say, let's just say it's 19. So we guess 19, and lo and behold, it actually is 19. So the term number that has a value of 124 is actually 19. If you wanted to look at the table, you could see that as well. Let me see here. We'll start the table at 15. Right, so 15 is 96, 16 is 103, 17, 18, 19 actually is 124 is what we expect. Okay, so the answer is 19. All right, one more question and then we're done here. All right, what we have here, let me get this out of the way. What we have here is one more problem. All right, so this says here, we have a pyramid that's made up of Coke cans, okay? The top row of the pyramid has 1 Coke can, and each lower row has 2 more cans than the row above it. If the pyramid has a total of 100 cans, how many rows are there altogether? All right, so here's kind of what they're saying. Let me see if I can draw it. Here's the first row, has 1 can. The second row has two more than the first one, so it would have 3 cans. So this is the first row, this is the second row, and then it says the third row would have 2 more than this, so it would be 1, 2, 3, 4, 5. So this is the third, these are rows. Make sure that's clear. All right, so it says there's a total of 100 cans. So how many rows are there? So we're trying to find the number of rows, okay? So that's what we're doing here, and we have our choices over here. So let's go back to our program, press enter again. All right, we have numbers in this case. We don't have any variables. So let's go, okay, no. All right, this would be an arithmetic series because each row is increasing by 2, all right? And we want to know the total number of rows. So we know that there's a total of 100 cans. So we'll choose option 2. The very first row has 1 can. The second row has 3 cans. And then it's saying, okay, what do we want to know? Now, in this case, we know the sum already. We know that there's 100 cans. What we don't know is how many rows that would be, or how many terms that would be, okay? So let's go down to option 2. And so it's saying, okay, then what's the sum? The sum is 100 because it tells us that there are 100 cans, all right? It tells us that there are 100 cans. So now we would put in 100, press enter, and it tells us that there are 10 terms, or an equivalent, that means that there are 10 rows. All right, and we're done. All right, so this program is called ASEQUERY, and basically it handles pretty much any kind of sequence or series that's arithmetic or geometric, all right? And it's very useful on the SAT, the ACT, or the Math Level 1, Math Level 2. All right, so I'm going to say so long. If you have any questions, leave comments. And if you like it, please subscribe. Thanks.